Predator becomes prey in the Florida Everglades as hundreds of hunters descend on the Sunshine State.
Something is killing pythons in the Florida Everglades with an impossible precision, and researchers are calling it deeply disturbing. For decades, the invasive Burmese python has ruled these swamps, wiping out 99% of small mammals and growing up to a monstrous 19 feet long. They were considered untouchable, the top invader with no real predator in sight. But what researchers are now seeing through hidden trail cameras is something that makes no sense. These giant snakes are being found dead, not torn apart, not partially eaten, but precisely struck at the exact point behind the skull where the spine connects. An extremely precise, targeted killing of something that was never supposed to be hunted. So, what in this swamp is killing a python like that? And how is it even able to do it? Let's dive in. The chilling discovery. It was early morning in the Florida Everglades. At the USGS field station, researcher Sarah Carver, a wildlife biologist working on invasive species tracking, checked the monitoring map like she did every day. Dozens of small GPS dots were moving across the screen. Each one was a tagged Burmese python, part of a long-term control program. Most of them moved slowly, in predictable patterns. But one dot was different. It belonged to a 13-foot Burmese python known in the tracking logs as Loki. Pythons can stay still for hours, sometimes days. But Sarah noticed something that didn't sit right. The signal wasn't deep inside thick swamp cover like usual resting points. Almost wrong for a predator that size. She got into the airboat, pushed through the channels of sawgrass, moving fast toward the coordinates. The closer she got, the stranger it felt. When she finally arrived, the GPS showed something impossible. She stepped out, scanning the ground. Just pine needles, scattered loosely over a small patch of earth. Then, she started pulling the needles apart. At first, there was nothing, just soil and damp ground underneath. Loki was there, a massive python, over 13 feet long, lifeless in the dirt. But what made her freeze wasn't just the size or the stillness that didn't match scavengers, didn't match decay, no tearing across the body, no feeding signs, an extremely clean, targeted break. Like something had gone straight for the most critical point in the body, her voice low when she finally spoke to the team arriving behind her. Something killed him, and it knew exactly where to strike. For years, scientists believed adult Burmese pythons had no natural predator in the Everglades. But Loki's body shattered that idea in a single morning. But what made it worse was the silence around the kill site. Almost like something had hidden it on purpose, leaving behind no traces or marks. If nothing in the Everglades was supposed to hunt a snake like this, then what did it? The impossible predator. The first reaction inside the USGS team wasn't fear, it was denial. A 13-foot Burmese python simply couldn't die like that. So the team returned to the site, this time with cameras, tracking gear. They expected something obvious. An alligator attack, maybe. Trail cameras were placed around the kill zone, covering every angle of movement through the sawgrass. For hours, nothing moved. Just when the team started thinking it was a dead end, something appeared in the footage. A bobcat, small, compact wildcat. But this one didn't behave like a normal bobcat. It walked straight to the site where Loki had been found, sat near the hidden body, and stayed there for hours. Researchers later reviewed the footage again and again, trying to explain what they were seeing. Because what came next made even less sense. The bobcat didn't just pass through the area. The camera caught only fragments of motion. The bobcat had struck the back of the python's neck area, the exact weak point behind the skull where the spine is exposed. One precise hit. When the footage ended, the researchers were left staring at something they couldn't immediately accept. A predator that small had killed something nearly 5 times its size. Once the team began reviewing older recordings and expanding camera coverage across nearby zones, the pattern started to appear again. Even more disturbing, more than one bobcat seemed to be doing it. None of it matched anything recorded in Florida wildlife history. Bobcats weren't supposed to coordinate or target prey so far outside their known limits. So now, the real question wasn't who killed the python, it was why an animal like this would ever attempt it in the first place. And to understand that, researchers had to step away from the predator itself and understand what the pythons did to the Everglades. Collapse of the Everglades. Burmese pythons were first spotted in Florida as early as 1979. And the reason was a totally unexpected accident that we'll talk about in a moment. Approximately 900 pythons were released instantly into the nearby wetlands. That single moment, a silent, expanding predator with no natural enemy in the region. For years after that, the spread went unnoticed in real terms. They stayed hidden, moving through water, grass, and swamp edges without drawing attention. The situation had already passed a critical point. The estimates came later, and they were staggering. But numbers alone didn't explain what came next. The real collapse showed up in the animals that used to define the region. Long-term surveys revealed a shocking breakdown in the food chain. Rabbits, both marsh rabbits and cottontails, had effectively disappeared in many core python zones. Opossums declined by 98.9%. Even bobcats, the same species now linked to Loki's death, showed an 87.5% decline. The Everglades food chain wasn't just shrinking. Every major prey species they consumed removed another layer of stability from the ecosystem, until large parts of the southern Everglades were left with almost no medium-sized mammals at all. Bobcats were not suddenly becoming aggressive hunters of massive snakes out of choice. They were being forced into survival patterns that didn't belong to them. The food chain left them with almost nothing to rely on, and in that pressure, behavior begins to shift. For normal biology to explain cleanly, the unnatural adaptation. Bobcats weren't just reacting against Burmese pythons anymore, almost calculated approach that left researchers completely speechless. A bobcat would find a python and not attack immediately. This wasn't random waiting, it was tracking behavior. The bobcat was studying how the snake moved. And then came the moment we already saw above in Loki's case. The bobcat wasn't attacking the body, where the python is strongest. It was targeting a very specific point. One clean strike there shuts down the entire nervous system. Even a 100-pound python collapses in seconds. There was another layer of discovery that changed everything again, and it was even more shocking. Bobcats weren't just developing this behavior independently. Across different regions of the Everglades, same waiting strategy, same observation behavior, same exact neck-targeting strike. Not just experienced adults. Even juveniles were attempting similar approaches, sometimes before fully leaving their early territories. This suggested something unusual for a wild predator population. A learned hunting strategy spreading between individuals, not through genetics, but through observation. Bobcats were picking up what worked and repeating it. Scientifically, this creates a contradiction. Evolution is supposed to be slow. Genetic change takes generations, sometimes thousands of years. But here, a complex hunting strategy is appearing across multiple animals. It looks less like evolution and more like real-time behavioral rewriting inside a living predator population. And that raises a question researchers can't ignore. How can an ecosystem push predator behavior to change this fast? They had to go back to the very same accident we talked about earlier, the arrival of the python itself. Birth of the crisis. The python crisis didn't begin with destruction, it began with convenience. In the 1970s and 80s, Burmese pythons became one of the most popular exotic pets in the United States. They were sold while still small, but that illusion didn't last long. A small hatchling quickly turns into a 15-foot, 150-pound predator. A snake that needs large amounts of food, constant care and space, most people simply cannot provide. And instead of handling it properly, many chose the easiest option. They released them right into the environment. A few isolated releases, but the real turning point didn't come from gradual release alone. It came on August 24, 1992. Hurricane Andrew. When the storm hit South Florida, it didn't just destroy homes and infrastructure. It tore apart a major exotic wildlife facility sitting near the edge of the Everglades. Inside that facility were hundreds of Burmese pythons. When the hurricane collapsed the structure, floodwaters carried enclosures away. Hundreds of snakes were released into the surrounding wetlands in a single event. One sudden mass entry into the wild. And from that moment, the system changed direction. In the early years, officials focused on rebuilding cities and infrastructure. The swamp was not a priority. And during that time, the snakes disappeared into the landscape. Early government surveys severely underestimated the situation, suggesting only a few dozen snakes might be present. But as years passed and sightings of native animals began to drop, the scale became impossible to ignore. Population models shifted drastically. Estimates ranged from tens of thousands to over 300,000 snakes across the Everglades system. But the real problem was deeper than numbers. Pythons are extremely difficult to detect. They blend into sawgrass, remain still for long periods, and can go unnoticed even in heavily surveyed regions. Researchers weren't actually counting snakes. They were measuring what was missing from the ecosystem. And what was missing was everything beneath them in the food chain. As we saw earlier, raccoons and opossums disappeared from large areas. Ground-nesting birds lost their survival stability. The entire population cycle began to collapse or swing unpredictably without balance. Even alligators, the natural engineers of the Everglades who maintain water flow in dry seasons, started competing with pythons for shelter sites known as alligator holes. That competition quietly disrupted water movement across the wetlands. What started as a hidden wildlife introduction had become a system-level shift across one of the most complex ecosystems in North America. But while all of this has already been happening inside the Florida Everglades for decades, the genetic escalation, the threat of the Burmese python is no longer just about size or appetite, it is about something far deeper. It's DNA. Because at this stage, the Burmese python is already one of the most efficient predators on the planet. When it feeds, its entire body changes. Within 48 hours of a large meal, organs like the heart, it is not a slow digestion process. It is a full biological reconfiguration. And the stomach acids are powerful enough, very little is left behind. That is why a single python can consume a deer whole, then survive for months without eating again. It is not just a predator, it is a biological system built for efficiency. Researchers are seeing something inside this system that changes everything. In recent genetic testing conducted on wild pythons, scientists at USGS analyzed samples from hundreds of individuals. Out of roughly 400 pythons tested, several showed something unexpected, genetic markers that do not belong to the pure Burmese lineage. They belong to the Indian rock python. Because this is not just a variation. This is hybridization happening inside the wild population. The Burmese python, by itself, it is a tropical species. Its survival is tied to heat. Cold weather is its natural boundary. Once temperatures drop below a certain point, it cannot survive. That single limitation is what has, until now, kept the invasion mostly trapped in South Florida. But the Indian rock python changes that equation. It is smaller, yes, but it survives in colder environments. It lives across regions of Asia where temperatures drop far below what Burmese pythons can handle. It is built for resistance, not just size. Now, both of these traits are appearing together. Size from one species, cold tolerance from another. A combination that should not naturally dominate, but is now being detected in real samples. And the implication is not small, it is geographical. Because if this hybrid trait spreads through the population, the barrier that has contained the invasion for decades begins to break. North Florida, once too cold for Burmese pythons, starts to become survivable. Then regions beyond that come into range. Areas that have never developed defenses against a predator like this suddenly become potential territory. For the first time, the invasion is no longer held back by geography. It is being shaped only by biology. And as these genetic shifts continue to appear inside the population, researchers begin to realize something even more unsettling. Because evolution inside a single species is one thing. But what happens when the entire ecosystem has to respond to a predator, the retaliation? By this point, the situation in the Everglades is no longer one-sided. It has turned into a full-scale response from both humans and nature at the same time. Professional python hunters are working deep inside the wetlands every night. A field specialist who has removed thousands of Burmese pythons over her career. She doesn't rely on machines alone. She uses direct tracking, visual spotting from elevated platforms, and experience built from years inside the swamp. Alongside that, teams are deploying tagging systems, tracking male pythons to locate breeding areas, and using environmental DNA testing, a method where even a small trace of genetic material in water can confirm whether a python has passed through an area. But even with all of this, there is a clear limitation. The removal effort is always behind the reproduction rate. For every snake taken out, more are already hidden deeper in the system. The swamp is too large, and while humans struggle to keep up, something else is happening inside the ecosystem itself. Nature is responding. Alligators are no longer just competing with pythons, they are actively hunting them. Bird species are getting involved too. Herons and hawks are targeting juvenile pythons, striking them before they can grow into full-sized threats. And then there are the bobcats. Now fully part of the system, they are no longer rare exceptions. They are becoming consistent predators of adult pythons. What is emerging is not a single defense mechanism, but a layered response across multiple species. A kind of self-adjusting system where each level of the food chain is reacting in its own way to remove or reduce the threat. But here is the problem. New reports from Florida wildlife monitoring teams suggest that python sightings and population estimates are continuing to rise in several regions. In some areas, the spread is no longer just stable. It is accelerating. And if this continues unchecked, researchers warn it may not remain a Florida-only problem for much longer. It could move beyond the Everglades entirely. And that is where the real concern sits. Because even with hunters, technology, and nature itself pushing back, the question is no longer whether the system is responding. It is whether that response is happening fast enough. So what do you think about this? Is this the only way to control something like this before it spreads further? Or is there a better alternative? Let us know your thoughts about this in the comments below. And if you found this video fascinating, make sure you give it a thumbs up. Also, consider subscribing to the channel if you haven't already, because we'll be uploading more incredible stories like this one in the coming weeks. Until then, see ya.